Hey everyone, I'm Chris Lesniak.
And I'm Rob Byer, and this is
the Debate Math Podcast. We have an exciting debate on today's episode.
And we thought we'd bring two educators on to debate the resolution, cut quadratics.
So here debating for the resolution that we should get rid of quadratics in high school math is math teacher and podcaster William Mealy. Hi, Mealy.
Hey, how you doing? Good to see you.
Nice to see you. Can you tell our listeners where you are and what your current role is?
Sure. I'm in North Carolina. I teach math 4. We teach what do they call it, like integrated math or whatever. So it's a relatively new, it's the second year that they've had the class, and it is essentially a little bit of what would be pre-calc, but some stuff that's not in there, and then a lot of statistics that have been kind of put in there. So and then I'm a podcaster for Unprofessional Development, but I know we'll be promoting that at the end. And then I actually threw my hat in the ring. Our department chair is leaving, so maybe I might be department chair at some point. We will see how that goes.
Ooh, interesting. Good luck with that.
Yeah.
And now the question we ask all of our guests is, when did math first become controversial to you?
Okay. So the biggest thing that became controversial to me was, I'm 53 years old. I learned math in the 70s and 80s, very much, sage on the stage, take the notes, algorithmic type stuff. And then I went to this training. It was my second year as a teacher, and they had all these different ideas about how to introduce stuff and having the answers somewhere where the kids could get them and all these things. And the idea that the answers are not this forbidden thing for the kids to have, but if they have the answer, they can actually learn from knowing the answer. And that but realizing that the process and knowing stuff isn't as important as how kids learn and getting to know the stuff and getting to develop those relationships with kids and really developing problem solving skills and talking about math and all that kind of stuff versus just knowing how to find the angles on the exterior of an octagon or whatever it is. So that's not important. Yeah.
Very good. Thank you.
And our educator arguing against the resolution is a teacher and doctoral candidate in mathematics education, Brendan Rawls. Hi, Brendan.
Hi. Good to see you.
Good to see you. Could you tell our listeners where you are and what your current role is?
Yeah. So I am in Suffolk, Virginia. I recently came to Suffolk from North Carolina.
Okay.
And I am a doctoral candidate at Liberty University, where my research is currently in the intersection of cognitive science and mathematics education.
Awesome. And then the question that we ask all of our guests, when did math first become controversial to you?
It was undergraduate, during my undergraduate degree at Appalachian State University. I was in class and I learned that people didn't believe in zero, back in the day, that wasn't a thing. And I was like, hold on, I understand that there is a progression to mathematics, but that seems pretty fundamental. And realized there was this whole exploration of these almost controversial topics in mathematics, the 16th century math duels with Tartaglia and some of the Pythagorean ideas regarding irrational numbers not being real and all of those things surrounding that. So it really broadened my idea of math from being an algorithmic thing to this whole cultural advancement that involved just so many different ideas.
Oh, wow. Hey, thank you very much. And thanks and welcome to both of you.
Yes. And with that, let's get into the debate. All right, we begin with opening statements from each of our speakers. You each have 2 minutes to present your arguments at the beginning here. And based on a coin flip before this recording, we're going to start with Mealy and your argument that we should cut quadratics. You have 2 minutes and your time begins now.
Okay. So the biggest premise I know, or my statement is that we need to trim the fat. Okay. If you've been teaching math for any time in anywhere from middle school to high school, probably even elementary school, you realize there's not enough time for the current content that you have. Every teacher is rushing through stuff. Kids don't get it. There's not time for remediation after you assess and you realize that the kids don't get it. And Just a little thing that's in quadratics, factoring a greater than 1. Okay, kids don't know how to do that, and most kids never get good at that. All right, so also quadratics, you may or may not know, they're basically just left over from the Cold War, Hidden Figures, Sputnik, when we were trying to launch missiles, launch rockets, all those kinds of things, where we were trying to beat the Ruskies. We're not doing that anymore. I mean, Russia's invading Ukraine, but it doesn't have anything to do with quadratics. All right. And the biggest thing really is make room for data analysis. We need data analysis, not calculators like in Hidden Figures. Okay. True data analytics takes time. It takes deep discussion, as well as learning how modeling and regressions work. Now, quadratics might find their way into that when we're doing some modeling and regressions, but we don't need to factor the quadratic formula, know the axis of symmetry, the discriminant, none of that stuff. So the counter argument is, what about when they need it for blah, 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 quadratics is, and then when they go to the next thing. Okay. First of all, those teachers remediated anyway. If you've taught statistics, calculus, upper level math, you know that the kids come to you not knowing quadratics anyway, even though it was taught in the prior subjects. Okay. So they can learn that. And then what about when they need it? What about when the kids need to know how to attach a faucet to their sink? What about when the kids need to know how to change their oil? There's lots of things that they need to know. Quadratics isn't one of them. Okay. And the last thing is Desmos, baby. Okay. Online calculators can do it all. And we don't need to know how all these things work. I know I use a lot of things that I don't know how they work, and it's fine. All right. Thank you.
Thank you, Mealy. And now we're going to hear from the opposing side with Brendan. Brendan, you have 2 minutes and your time begins now.
All right. So mathematics is a story across thousands of years and many cultures, and quadratics was very much a vital part of that story. And so I believe we need quadratics in high school math classrooms, and I have 3 reasons for that belief. So first, quadratics serves as a natural bridge from linear to general polynomial functions. The progression from linear to quadratics to cubics and so on is kind of akin to a step ladder that makes generalizing polynomials even possible, and then later calculus possible. So students understand x-intercepts and linear functions, and then we help them relate those types of things to factors of quadratic expressions and solutions to quadratic equations. And then from there, we take that and we build upon that to include the degree of the polynomial relating to the potential x-intercepts of the polynomial equation. My second reason is that quadratics is unique in the fact that it lies in a position where you can tie in so many cultural aspects as well as combine algebra and geometry. So for instance, instead of just learning about quadratics and factoring, learn about the Babylonians and how they saw rudimentary quadratics, and expand that to include Euclid and his geometric interpretations of quadratics. And then also take that to Brahmagupta and Indian mathematics and learn how they advanced it towards negative numbers, and culminate all of this to the Islamic Empire as they really are doing things that we are doing that we see as modern today. And then my third reason is not my fun reason, but it is the fact that we certainly have a staple in the American diet of quadratic functions in SAT work, ACT work, ASVAB work, T's nursing entrance exam, and so many college test prep. So by cutting it, and it is unfortunately putting students at a position that they're not going to have access to those. They're not going to have access to that type of preparation for those exams and potentially opening doors for their future.
All right. Thank you, guys. You gave us a bunch to think about already. I love this diving in here. And like on the pro side, Mealy, you're saying like it's a little outdated, a little excessive, like trim the fat, and let's focus on things that are really relevant, which is like data science type stuff. Yeah. And then Brendan, on the other side, you're saying, well, there's this, large cultural history behind it and the natural progression of the different degrees of polynomials that we study and stuff. And also its relevance to testing in calculus and nursing and things like that. And so I guess that brings me to my first question. Just what's the point? Like, what's the goal with quadratics in high school? Like, is there a clear purpose for teachers? And either one of you can jump in on that.
Okay, I was going to say, and I was going to respond to what he says. Like some of the stuff you said about quadratics is beautiful and wonderful in the history and all of that. And I see a value in that. But not in the high school curriculum, and I probably will keep coming back to this, but there's only so much room and there's only so much time, and there's other stuff that I value above it. There's a million math topics that are fun to explore and really cool and interesting and have all kinds of cultural significance. You can tie them to history and neat things, but but that's not what quadratics is currently, and I doubt it ever will be that. And it just takes up a huge chunk of time, and we have other stuff.
I agree with what you're saying there. I think a bit of the chunk of time would be alleviated. You mentioned factoring, and I think that that's probably what everyone's mind goes to when we think of like the perils of quadratics is the factoring aspect. And I'm not going to be someone who says that that's not a problem, but I will say that the problem, I believe, probably lies somewhere other than the quadratics. I think it's probably a little bit more fundamental, and that students that tend to struggle in factoring with a being greater than one also probably tend to struggle with automaticity of multiplication facts. And so if that was stored in long-term memory before they got to quadratics, then quadratics wouldn't require nearly as much time. And so it might not necessarily be a quadratic issue, but rather prior grade issue.
Yeah, I agree that. But when they get to you, you don't have time to teach the multiplication tables because you've
Absolutely
got
not.
17 things to do. And I've been teaching 11 years, and the percentage of kids that have their math facts down it seems to get smaller on a yearly basis.
Absolutely. And so I in response to one of your other points about data science, I absolutely love data science. I'm actually I teach computer science foundations, and a big aspect of computer science foundations in Virginia is data science. And so I love it. But my only issue is that with data science, I tend to feel like we might have a conceptual understanding issue with students in the sense that we teach them a lot of tools, like teaching them regression tools, but how much of that becomes conceptual versus how do you, like, I don't necessarily know 100% if I can dictate whether or not a student understands what's going on when you use computers to do regression. Yeah. And so data science, I think, has a ton of potential, and I love data science, and I wish that it was integrated more. But I do feel like there's some problems that probably have to be worked out in data science education that likely fall into the when is it okay for algorithmic and procedural thinking, which is another aspect of coding and data science, and then when is it okay, when do we divide that into a conceptual understanding? And so until that's worked out, I feel like it's going to end up being another example of like plug and chug to some extent. But
I think that it lends itself more to, and teachers have to be open to doing this, is having those debates in math class where we can just play with statistics and we can play with percentages and say, hey, why should you get this car versus that car? And based on, looking at the mileage and the repairs and the how much it's going to cost for gas and the financing and what you need for all this kind of things. And you can say, well, I've got these statistics and all that. And I think when it comes to the regressions, and I think that's really only a part of it. But if we can get into predicting, going, hey, what do you think will happen? Why do you think this will happen? Can we prove that will happen? Why do you think this? And look at current trends that are going on and say, hey, this is what's happening, whether it's with the stock market or the COVID numbers or the gas prices. And they go, hey, let's do this at the beginning of class. And we're all going to put all these predictions and we're going to put them on a spreadsheet, and we're going to see 9 weeks from now what you guys how close your predictions were and whether or not we can actually model these things or not. And there's so many opportunities for things like that.
So I want to jump in real quick, because I want to come to you, Mealy, as we were talking about like potentially cutting quadratics. If we were to cut quadratics, so are we going to say that students would only see things that are linear? Or how would you envision, would we not show it to them at all? Or is there a version of quadratics that we would show students?
So, and that's something where you have to get down to it. And it really comes down to the trimming the fat. And I had this conversation with lots of people, lots of time. When the idea for Common Core was presented to me before it was actually rolled out, the idea is that we are going to get a core of things that they will need for college, which would be given to teachers. That was supposed to be 60% of their instructional time for the course, And then teachers could add 40% onto that, whatever they, you want to go down some road with the Babylonians and zero, you want to go down with quadratics and, get out some trebuchets and do that, or wherever it is you want to go, then do that. So when it comes to, would they see the quadratics at all in terms of like solving and knowing that, hey, there's multiple solutions versus one solution to problems? I guess at some point you could show that to them, but if they don't get to it and in their high school career, I'm not worried about it. You know what I mean? I just realized, someone said to me a long time ago when I was doing my student teaching, they're like, you're not teaching math majors, and they're not math majors, our students. There might be some math majors in there and they can grasp onto some stuff, and you have time to do some extensions and say, hey, what do you think? How do you think you would figure this out? And take them down some places when those kids that can like literally, do things so quickly, and give them some kind of exploratory things. But we need to get kids ready for college and for the real world and being able to figure out some things. And I don't think there's a job today that on some level, whether it's on a really small level or on a really deep level, that some kind of data analytics isn't happening. And I know that takes developing that part of your brain, takes a lot of conversation, takes a lot of repetition, takes a lot of playing what if games with them. And quadratics take up, in my state, quadratics take up roughly, for their second year of the integrated math, it takes up roughly 45% of the year. I mean, it's just insane.
I taught math too in North Carolina on the Outer Banks. So
yeah. And how much of your year did it take up?
45% is probably a reasonable
pretty close
estimate.
Yeah, that's a lot.
Well, and Brendan, that go ahead, Amelia. You can go ahead.
I was gonna say, and it was just I don't think that it's serving the kids right and preparing them. And obviously, there's things in high school we're gonna learn. We all know there's only so much of high school that we can even remember, but I think that the more we can give them opportunities to go in, if data analytics took up 45%, wouldn't that be much better? And if we want to throw in like a week of quadratics, fine, whatever, throw in a week of quadratics, show them some stuff, but just don't have them memorizing the quadratic formula and having to factor a greater than 1. And, like I said, axis of symmetry is like a day for some classes, and, and all these things that are just, not as helpful as other things.
Well, and then going to you, Brendan, are there certain aspects of quadratics that we teach that, like Mealy said, that we could maybe trim? Maybe it's something that could be pushed, maybe for college even. Like we teach certain things in high school, and other things belong in college when you're on a major path. Is there something about quadratics that you think that maybe we could trim?
I think some aspects of quadratics have started already to be trimmed. So like the connection to conics, and at least in Virginia was an Algebra 2 type of situation, and it has faded out. And I think that some things, and I kind of like conics too. I'm not one to say I don't. I think it really does provide a geometric and algebraic connection. But I think to some extent it is being phased out. As far as what we can continue to phase out, I'm not necessarily against taking factoring and moving some of the emphasis off of factoring and making it more of an interpretation of shape, rather than, because I think that's probably the goal of Algebra 2, is you have been working with these patterns, and we have this pattern and we call it linear, and then we have another pattern with a curve and we call this a quadratic, and then we add another pattern and it's a cubic, and I think the shape aspect of it and connecting general topics such as x-intercepts and those being related to maybe break-even points in a business, I think that I'm okay with reducing the amount of factoring, because like Mealy said, we have kids who cannot multiply efficiently in their head. And so until we have kids that can multiply efficiently. Factoring is a losing battle.
Ooh, how about when B is 1 or -1? Watch their head spin. Okay.
Yeah.
Oh my goodness. Like, what? Huh?
There's
I
no
don't even know
number
what
there.
that is. There's nothing there. I don't know what those numbers could be.
Absolutely.
Yeah. Though we'll say this, Brandon, I completely forgot about it because I haven't taught. We have Math 3 as well. I don't know how much Math 3 you taught, and where it falls in other schools, but rational equations and rational expressions and rational
Yeah.
all the operations with rationals it's just more factoring. What I mean? It's 90% factoring. It's a little bit fractions. I'm like, oh, we're gonna take fractions and factoring, the two things that you're worst at, and have you a unit of that and see how we can bring your grades down, boys and girls.
Well, I think that a lot of those, I think the goal of not Math 3, so and that does correspond to Virginia's Algebra 2, is I think a big goal of that is the kids from K to geometry have learned all of these things. And I think the goal of Algebra 2 in the original framer's mind was that of generalization. It was, how can you look at the graph and find key features, and then how can you do it by hand? And I am willing to say that the by hand part isn't necessarily as important. 100%.
Right.
Now, am I against cutting out understanding the key features and relating those to the next type, like using quadratics as a stepping stone to generalize polynomials? That's kind of where I draw the line of it. But the by hand stuff, like, I am completely okay with being like, it's not necessary.
Oh, and Desmos.
Yeah, a beautiful tool.
Add holes to, like, we want to see holes in Desmos. Please figure that out. I don't know what you need to do, but I want a hole.
Have you zoomed in on a hole before on Desmos?
No. Can you see one?
Yeah, it breaks up. And I always tell my students, this is why we're smarter than computers, is that when you zoom in on a hole on Desmos, like, you have to get really in there. The computer can't interpret it. And so it creates these like crazy fractal images because it doesn't quite understand the division by 0 that's creating the hole.
Wow, I'm doing that tomorrow. Okay.
It's cool.
Well, hold on. Let me just change topics a little bit here. Brandon, let me stick with you for a second. You mentioned like your nursing students and students in the future, like things they need in the way the system currently is, right?
Yeah.
So if a teacher's listening to this and has no plan of what they're going to do with their quadratic units, can you just give them some advice? What are the key things about quadratics you know they need for their future exams or courses in whatever field they're in?
Absolutely. So I would say the quadratic formula is not necessarily as important as people make it out to be. You have other options. Completing the square and connecting it to geometry is significantly better, faster, and more efficient than the quadratic formula. So I like completing the square. If you had to pick one or the other, because you have a multitude. Quadratics really falls into the idea of 90% find x-intercepts and roots and solutions, and 10% other stuff. And unfortunately, I hate that dichotomy of it, but that's currently the way the situation is. So if you're going to trim the fat, I personally, even though I teach both completing the square and quadratic formula, if I had the perfect world, I'd cut quadratic formula all day. And I'd say this is a way, and I would say this is literally how our ancestors, so our people down our lineage, or before us that created this lineage, that this is how they did this, was a completing the square method. And then also I would say that another important aspect is the generalization. I really try to hit home that the fundamental theorem of algebra is most, I feel like my kids' eyes light up most when I can relate the squared to the number of times it crosses the x-axis, or relate the squared to the number of imaginary solutions, which is also another important aspect of quadratics. As much as I do think we need to, get away from some of the rote aspects of quadratics, there is also some aspects that expands upon the kids' knowledge of, and what I mean by that is you can't access imaginary solutions without doing it by hand. And so as much as we wouldn't want to do this by hand, like, we have these crazy tools like Desmos, and it's fun to say it doesn't cross the x-axis, but it has a squared, so we know it has to have 2 solutions. So where might those be? And then we can build a different way to find those. That, I think that's really important, and especially when they get further on, and because as much as it as much as it is important to do those things for the sake of doing them, we are also preparing our students for something else. And I hate to say it like this, but it does in our current system feel like a perpetual cycle of preparation.
Yeah.
And because of that,
and it feels like an excuse, you know what I mean? It's
yeah,
like,
well,
yeah,
it does. It certainly does.
yeah.
And
yeah.
so if
It's
I
like
were
we know this road goes like almost nowhere, but you've got about 5 more miles to go. So let me tell you where it turns.
I love the analogy that it works. So in the goal of preparing them for the next class, I would say stick to one level or one method for solving quadratics, preferably completing the square, because it works every single time. And then secondly, really, really hone in on the geometric aspects of quadratics, and why we relate some of the hands-on things that we're doing to the picture in front of us.
Nice.
There,
And
I was gonna say there are online calculators that you just put A, B, and C in, and it'll tell you, it'll find the imaginary roots for you. It'll find it in you know, in a rational form or a decimal form. So those are available to them as well to kind of use as tools, as opposed to try and, you know, because then we get to like simplifying square roots and what's the value of that, and that we're back to the multiplication facts again when we come to simplifying, you know,
100%.
radicals. Yeah.
That multiplication facts are the single, in my opinion, the single greatest aspect of in the current system. If we want kids to like be the A student or whatever that means, right? Like it's multiplication facts is like what they need coming into your class.
Right.
Now, is it necessarily the most important thing though? That's
if you allow them to, you know, use this online calculator to solve the quadratic, like plug in ABC, should we still teach them some of the methods first? Should they know what's going on, or would you be okay with them just jumping right to that calculation, the computer calculation?
Who is that question directed to?
Yeah, I was gonna say.
Start with Mealy because you brought it up.
Okay. Well, I was gonna say the one that I've used, and I know I've got somewhere in my bookmarks. It shows step by step, so you can actually, you know, on the board go, well, here's what's happening and here's what's going on, and you know, now obviously the grasp of that has to do with multiplication facts a little bit, you know what I mean? But you can, you know, you can show that, but you can even have them, you know, I would teach them one time when I was teaching them to simplify radicals. When you're done, put like, you know, 4 square root of 2 in and C, and then to get the decimal and put square root of 32 in, and notice that it's the same decimal. And like, you can always go behind and check your work like that, or to kind of get that understanding of what's going on with that, or take a minute and kind of show that. That's one of those things where like, okay, I'm going to show that. There's gonna be like 4 kids are gonna be like, oh, and other kids are gonna be like, so where do I put the numbers, and what's A and what's B and what's C? And you have to serve, you know, both aspects of your class. But I think that, you know, letting them see the steps is probably easier than trying to like take the time that's going to drag your class down of doing it by hand one time, at least having them do it by hand one time.
And Brendan, what were you going to say?
I was going to say that I think it's important to do it by hand at first. And the reason being is I don't want to, like Mealy said, trim the fat, but I don't want to trim the fat for the sake of trimming conceptual understanding. And so I want to make sure that I am as authentic to the task as possible, and then say, now that we understand this, and I'm not saying bog down their working memory to the point where this is frustrating. I don't mean that. Once you get to that step, we have lost the child, and we have to revamp our plan that day. But I want to get them to a point where they feel comfortable just explaining what's going on, and then give them tools to make it easier to explain what's going on. Like interpret the tools instead of using the tools.
Sure. Yeah. All right. And talking more about the future goals. So Mealy, in your world, if we cut quadratics, what do like students who want to become engineers or physics majors, like where do they see that in preparation for their future, or do they need to?
Right. And I don't think that there's too many engineers that are using the quadratic formula and doing it, whether even in Desmos or by hand on a regular basis. You know what I mean? People who are, launching rockets, the code is written, you know, and it's in there, and there's other things that they are working on that are beyond that and above that. Now, should they have some idea that, you know, what's going on, and gravity, and, you know, and all that stuff that's you know, entered into why this thing is going into a parabola. But you know, like I said, we all have like learned things on the job. You know, we're teachers here. You know, no one taught me how to use the online grading software. You know, no one taught me how to use Zoom, Kahoot, all those kind of things. I learned things on the job. You know what I mean? So physics engineers, plumbers, nurses, you know, all these people, you learn so much more on the job. And so I'm not really worried about that. Now, the testing aspect, that grinds my gears. And that's a whole other debate. You know what I mean? Like, you know, and so are we handicapping the kids from getting into X school because they're not going to know quadratics when they take the SAT or the ACT? And it's like the horse and the cart, and it's all mixed in, and it's one horrible mess. Because I still rather cut it. You know, I'd rather be on the end of doing it and say, hey, you might get a couple of questions wrong, or hey, here's some things you need if you think you're going to Duke or Harvard or Stanford or whatever, to help you out. But, you know, I think the majority of my students, even with quadratics, probably aren't doing that great on the quadratic questions that pop up on those things.
And Brendan, so, you know, in your opening, you mentioned about, you know, students needing it for testing, which isn't the fun one, right? That was, you said that's not your fun one. So what do you say to those who say, I'm never going to use this in real life? Why are you teaching this to me?
So if you have an answer to that question, please let me know, right? Because that, I think the question can be applied to any topic. I've had kids tell me this about linear equations. I've had kids telling me about the when we go over SOHCAHTOA, you know, and we talk about right triangle trigonometry. But when it's specifically in quadratics, I understand what the issue is, you know, like it feels like it is a game of algebraic manipulation rather than a game of usefulness. Mm-hmm. And it feels like that. And I am sorry that the current system has them in that position. And I want to change that. However, that change has to come from someone above me. Even like I can't, as a teacher, it's not my job nor responsibility to pick and choose curriculum. That is, if I want to be a part of the state team and make my argument for that, I'm 100% for that. I was a math liaison for Currituck County writing the Math 4 standards 3 years ago.
Thank you. They are beautiful. And there are just enough of them. It is the best. We have 4 levels of math, and Math 4 has by far the least amount of standards, probably like almost half as much as Math 2 or Math 3.
Yeah.
You know,
I feel like Math 1 had a ton. I remember I taught Math 1 a couple years there, and I mean, it was like 110 standards in 90 days. I mean,
right.
It felt like a lot.
Yeah.
And so I kind of lost where I was at.
But you said it was not our job to like.
Yeah, it's unfortunately in the classroom setting, it's not our job to pick and choose what is being taught. And what is being decided at the state level has a lot to do with what is being implemented at the collegiate level. And so when you take a look at math entrance exams, and like even in North Carolina, East Carolina University has a math entrance test. I don't know if Amelia, you've ever used the East Carolina math entrance test.
No, but I've given my kids I forget what it is. It's this thing where it's like basically a conglomeration of all the North Carolina entrance exams to see where you're going to be placed when you go, if you're going to be
absolutely. So
remediation or be able to take
100%. I think we're talking about the same thing. Absolutely.
It might be.
And so I think what states do is we take a look at we unfortunately adopt a one size fits all mentality in terms of every child is going to do the exact same thing, and every kid's a math major and engineer. And so therefore quadratics is the most important thing they'll ever know. And I'm being sarcastic there, but I'm saying states adopt those types of mindsets because colleges also in their entrance exams say that to be a digital media specialist, to get a degree in digital media, you are going to need to you're going to need to be able to solve some logarithmic equations.
Oh God.
You know, that's what we say. I mean, it's an unfortunate
Liars.
situation. Yeah, I know. And so under the current circumstance, I feel like we can't cut quadratics out of necessity of helping some of these kids get to the next level. In a idealistic world, I would love to say, let's completely minimize what we're doing and implement data science wholeheartedly. But I just feel like we're doing a disservice at the moment to the kids. So what I'd tell the child is bear with me.
Oh, wow. Well, I actually have a good answer to that question that you asked him. Okay. And I do this at the beginning of the school year when I talk about the fact that because I'm like, I need to get you on my side and know that there's gonna be some times where we're gonna doing something that you're gonna be like, why are we doing this? And first of all, I was taught my second year, someone said, when a kid says, when am I going to use this in real life? They don't actually want to know the answer. That is code for I'm frustrated and I feel less than, and I've got two choices. Either I'm stupid or this is stupid. And I pick this is stupid, not I'm stupid. And that's all they're doing. But I say to them, you'll see athletes out there with the giant truck tires and they're flipping the truck tires. I'm like, there's no truck tires on the football field or the basketball court. I'm like, why are they flipping the truck tires? And they're like, well, that makes them stronger. So when they go out there and they have to like do something, their muscles are strong. And I'm like, and that is why we do SOHCAHTOA. I'm developing the parts of your brain muscles that need to be able to recognize patterns, identify the differences, tell when, and discover nuances as to know whether or not I'm solving for, realize that if it's angle A or angle B, it makes a difference when I say sine of A or sine of B. That's a huge thing that my kids struggle with. They want to like, oh, this is always the opposite, and realize that that's not, sometimes it's not, sometimes that's the adjacent. And that part of your brain that you're developing when you're doing that is going to help you in whatever job you are, because we all will have parts of our jobs where we have to go, sometimes this is this thing and sometimes that's that thing, depending on the situation or the person or the object that's being related to that thing. And so I use the lifting of things and exercises that you do outside of the athletic endeavor that develop those muscles for that endeavor. And I'm like, and that's what we're doing with you right now. Whether they buy that or not, I don't know, but it makes me feel better.
Yeah.
Go ahead, Brendan. You can wrap it up.
I was going to say, I feel like we all, like when I have a kid actually say that, I feel like I always try to come up with like a real life example of it. But I don't think that like Mealy said, I don't think that that's actually what they need or they mean. And so I like what you said there. That'll be the next thing I say.
Mealy, coming back to you. So if we were to get rid of quadratics, what happens to calculus and any other advanced math class?
Okay, first of all, let's get rid of calculus too. Okay, so sorry, calculus lovers, get rid of it. Okay, what's going to happen to the guy that makes horseshoes? They said when the car came along, what's he going to do? Okay, how's he going to have a living? What about the guy that scoops the horse poop off the streets? He'll have no job. Okay, so what? We're getting in our cars and we're driving. Well, get in my data analytic Tesla and let's ride, baby. Okay. So will someone still study calculus? Sure. There's people studying Latin. All right. There's people that are studying all sorts of, wonderful things. There are people who make candles, right? Even though we have light bulbs. And there's nothing wrong with the people making candles. There's nothing wrong with the people that want to study calculus. Just get it out of my high school and take it somewhere else where you can be in some club or some kind of little online Discord and do your calculus there.
Underground calculus. So let me ask both of you, and maybe Brendan, you can start. So I'm thinking about modeling, as you look at data or just any kind of collection of points that whatever data you collect and you graph it, you want to make a line of best fit or a curve of best fit. So do we touch on quadratics? Do we touch on exponentials, like the shape of that? Like how deep does your cut go, Mealy? And Brendan, let's start with you. Like, what do you really want to keep in terms of like modeling, and then we'll go to see what Mealy says.
So I think the biggest issue with modeling is that a lot of times when we have students modeling, we have them creating models for the sake of creating models and not discussing models as whether they are a good model or a bad model. And what I mean by that is there's like several assumptions just to do at the college level, to publish a academic paper using linear regression, there's like 5 assumptions that have to be true for you to even do it. And we don't discuss whether or not these assumptions are true at the high school level. And it's probably because for the most part, some of these assumptions are a little advanced, right? Like we're not doing Levine test to figure out if there's a normality amongst residuals, right? So, but the idea of that isn't really that far, right? Like we can ask the kids, we can figure out what residuals are. That's not a difficult topic. And we can ask, are there as many, are the size of the residuals relatively spaced around the line of regression? Like, does it look like there's an even pattern on both sides? Like there's as many dots above as there is below, right? And so that's an assumption we might talk about, but there's like several others. And so if we were to include more data science, I would love to include more assumption testing in data science so that we can discuss when is something a good test or when is something a good model or a bad model. And as far as what type of data we could use, I think linear and exponential are the most prominent when it comes to data science. But there's certainly, if we expand data science, and there's certainly in that expansion room to include polynomial regression, which includes quadratic regression.
So Mealy, if you cut quadratics, would you also cut exponentials and other parent graphs?
I don't think it's bad for them to see them, and I don't and for them to understand that if we put X here, we put X there, we have these types of things, and kind of look at those equations and kind of play with them and see what they can do. But let's make them more like play things. Like one of the things that I do in my class, and it kind of helps them with multiple things, is I give them what I call like a Lego box, and it's got a couple quadratics, some absolute value, an exponential, like a sine function, a couple linears, and then they have to make a drawing with Desmos with those pieces, and so they learn about restricting domains and restricting ranges, and they learn how to what causes the shifts or transformations of the functions as they're doing all sorts of things. We kind of play around with that and look at what happens if I change this number, what happens if I change that number. And they might not necessarily know that this is called a quadratic or this is called a or whatever function, but they're seeing when they're getting their hands in it and getting dirty and realizing, hey, different numbers change things different way, and the way for me to learn what happens when this number gets bigger, this number gets smaller, is just to put it in the thing there and make the number bigger or small and go, oh look, the smiley face on the thing I was making got wider, or the whatever it is got steeper, or whatever it is, or went left or right or up or down. And sometimes, why is it why is this one positive goes right, but this one that's or rather when this one's positive it goes left, when this one's positive it goes right, or whatever it is, depending on different things. And so kind of playing around with that, and that can lead to conversations and all of that. So do we take it out? What I think we need to do is, we can have them in there, we cannot have them in there. But I just think, well, like I said, that my biggest argument is that quadratics takes up such a huge chunk, and because it's there, there's other stuff that can't be there. And I don't actually even know, haven't seen it done, like from 9th to 12th grade, making data analysts or data analytics and data science as important as factoring and quadratics and all that kind of thing, and then see how much room is this going to take up. And once we're done, with that, what's left? What else can we put on there? Or can we just kind of like mix and match and have some stuff that's just on there for whatever reason? I don't know. Did I answer the question?
Yeah, I think you do.
Okay.
And I think that concludes our questioning round. All right, we'll now end by giving each side 2 minutes to make their final arguments to you.
And first up, we will begin with Mealy. Mealy,
Okay.
You may begin now.
All right, thank you. So back to just what I've said, what I think I've been saying all along is that quadratics takes up a lot of time, and that there are a lot of mathematical things that have value and that we can have fun with and all that kind of stuff. But these are high school students, and we want to, while sometimes giving them things that they'll never use again, because that's just the nature of high school, we want to minimize that and maximize giving them things that they will use in their real life. And what that's going to be more times than not is going to be some level of data analysis, whether it's on the job or off the job, when they're digesting news, or they're getting something from their from a report from their doctor, or they're looking at their bank accounts, whatever it is, they're going to need to have developed the data analytical skills. And could quadratics be a small part of that when we're doing that? Sure, quadratics, you can come along for the ride, but you are no longer the star of the show. And just sit back and do that. And I'm really going to like try and put calculus only on Discord from now on as well. So I think that's good.
Very good. And with the final word, we have Brendan.
All right. So quadratics are important. Is there room for trimming? Absolutely. I think that there should certainly be a point where factoring is not the main goal of quadratics. It is absolutely not. However, I do think some of the skills that Mealy has brought up in data analysis are somewhat inherent in mathematics as a whole. For instance, bank account information, as you mentioned briefly, that I would hope that even with quadratic analysis, using quadratics and word problems, and just understanding quadratics, like there's just some commonalities in mathematical reasoning that they could use as they apply that forward. Additionally, I think quadratics are fundamental in terms of getting kids to generalizing polynomials. I do not think you can cut them and still be able to understand polynomials to the degree that we would like students to. And I understand that we currently have a system where it is calculus dominant, and it would make more sense if we switch to a statistics dominant type of curriculum. But unfortunately, in the circumstances that we're in at the moment, it is not feasible, nor is it a situation that we can control. It is definitely above us, and I would love to have a vote in that, though.
All right, thank you both. And this concludes our debate. You've given us so much to think about, and to reflect on during this episode.
Yeah, that was a lot of fun, guys. But now it's up to our listeners to take a moment, ponder the arguments, and consider what resonated with you. We'd love to have you go to our Twitter @DebateMathPod to vote for who you think was more convincing in this debate.
We will leave it up for 1 week and then tally results before our next episode.
And again, huge thanks to both of our guests. You guys were wonderful. You were thoughtful, respectful. I think we found lots of places of agreement and nuance in here. It was a great discussion. I love how we're turning debate into a great discussion here.
And as always, thanks to all you who are listening. We hope you enjoyed and learned from this episode. And don't forget to go out and vote.
And as we wrap up, Mealy, where can listeners find you or listen to you or all these things?
Yeah. So if you want more ramblings and nonsense about math, but we talk about all education topics on my podcast. It's called Unprofessional Development. So first of all, if you just Google unprofessional development, I think that you will find us most times, especially if you Google unprofessional development Mealy or unprofessional development Tony Danza, who is our claim to fame, having him on our podcast, and on Twitter @unprocast. But I think if you and that's always in our show notes for our podcast. So that's where to find me. I think I'm pretty easily found.
And Brendan, where can listeners find you?
You can find me at Sum of Angles on Twitter.
Wonderful.
That's SUM, right?
Yeah, SUM.
Yep. We'll drop that in the show notes also.
All right. Thank you both. That concludes our debate.